Buenos días, buenas tardes, buenas noches en función de la parte del planeta en los que os encontréis. Hoy tengo el gusto y el honor de presentaros a Jonathan Reichenthal, quien es el CEO de Human Future. Un hombre de negocios, un emprendedor, un experto en tecnología, quien es además un experto en blockchain, una tecnología absolutamente necesaria en el mundo, en la cuarta revolución industrial. Jonathan ha sido galardonado con numerosos premios como CIO varias veces en los Estados Unidos y además es un experto, tanto un consultor para gobiernos y para grandes empresas que están haciendo su transformación y la implementación de blockchain. So Jonathan, welcome.
Hi Pablo, good to see you.
My pleasure. So the floor is yours.
Thank you. Well, I'd like to spend the next few minutes talking about what is blockchain and how might blockchain be used in the enterprise. For the next few minutes, I'd like to talk to you about what blockchain is and some of the incredible uses that are being adopted for this technology. I'd like to give some background first. You know, if you use a computer or use an application, you're probably using a database. Databases are very important in how we power applications, how we store data, and they have to be secured for the most part. And so we have used databases for a few decades, and whilst they served us well, they also have some limitations. They're not always as secure as we would like. Often they're centrally managed, so there's a governing body that's required, and they do get hacked. So trying to make our databases and the internet in general more trustworthy is a very important goal. If the internet is going to continue to grow and be a very important part of society and of the global economy, we're going to have to make sure that we have innovation that shores up that trust. And so it's an essential part of the future of the internet, and as you'll see in a few moments, a driving factor in the emergence of some new technology. The other characteristic about a traditional database that will become relevant here soon is that databases would typically reside on what we might call a central server. So all the nodes or clients that are accessing data are connected to a central place. Now that's very effective because you have only one version of the database to update, and you can focus on that and you can administer it through that central database. But it's also a weakness. It means that you have one place to hack. It also means if that database goes down, nobody can access the data on it. Now these are issues, but we've come up with some really great technology over the years that helps to protect these limitations. But it's not perfect, and as you know, we still have big issues with systems going down and with security. So what we need to be starting to think about is, well, what would an alternative look like? How could we architect databases differently such that they had better security, that there wasn't necessarily just central governance, but distributed governance? And we get into the first term here that, again, will make a little bit more sense as we progress through this short talk. And we have what's called, the first thing is the distributed ledger technology. Basically what we're saying here, we've jumped to a bit of a complicated word here, but rather than having a database that is on a central computer, we're going to distribute the technology, the database, onto multiple computers. Actually, all the people who use the database are going to get a copy of it. And they're going to store their data in logical rows and columns, just like in a ledger. And we call this distributed ledger technology. Now, it doesn't make sense yet, but it will in a few moments. So you have a traditional database. I've spoken about the fact that it has to be centralized, typically. Records can be modified centrally or by the different clients accessing it. And again, typically we have central management, so there is some governance body that's required. Now compare that with a distributed ledger technology or a blockchain database. These are often used interchangeably. And you get decentralization. You have another characteristic, which is the database doesn't have a delete function. All records are stored. And again, that will be interesting in a little while. And we get rid of central management. So no longer are we dependent on a central form of governance for managing the data on that central server. Okay, so that's the technology at a very high level. But let's talk about the origin. What drove sort of the innovation to arrive at a place where we could think about databases differently and how we store and move around not only data but items of value? And it starts in 2008 with a paper written by a guy called Satoshi Nakamoto. He wrote a paper called Bitcoin, a peer-to-peer electronic cash system, and published it on a bulletin board online. And by the way, we don't know who Satoshi Nakamoto is. It's one of those little technology mysteries that makes blockchain even more intriguing. But the paper was published, and about a year later, the technology was built from the paper. So in 2009, you had this, in fact, this digital money, which is what Bitcoin is. And it was powered by blockchain technology. The way in which you make Bitcoin work is by using a distributed ledger technology solution. And so you have to think about blockchain being that underlying technology, and then Bitcoin, and you'll see in a little while, other cryptocurrencies and other applications running on top of it. So it's like in a traditional technology architecture, you have applications that run on top of a database. Fundamentally, blockchain is a database. There are different participants, so we get into a little bit of the detail here. In a blockchain environment, you have a user. So we'll think of the user in this case being somebody who wants to use Bitcoin as a digital currency. Then you have the power of the group of users, and I'll come back to that in a moment, and you have this notion of a miner. So whilst the person makes sense, what is a group and what is a miner? It's one of the unique things that are written about in this Satoshi Nakamoto paper. And it's why blockchain and crypto is so compelling now. It's because of these unique features. So let's start with the miner. Now, in Bitcoin, there has to be certain users on the network. So let's say there are 1,000 Bitcoin users. I'm making that number up. Only a small proportion need to be miners. And the miners help to validate transactions, right? And why do they do this? What's their incentive? Well, they get a little bit of Bitcoin given to them over the network. So that motivates lots of people to participate as miners. Not everybody wins. Only one miner wins for every group of transactions. But it does give the system rigor. And as we'll see in the full course, there's a very important role for the miner, and we need to describe that more. But that fundamentally, it's the way in which transactions are approved. Now, once the miner does his or her work, the transaction isn't ready yet to be approved and distributed over the network. It has to go to the group, the whole group. And why it goes to the group is we get into another concept which is about consensus. The group has to approve the transaction. So the miner does it first, wins the activity, gets a little bit of Bitcoin, then distributes what him or her has done, and then the whole group approves the transaction. It's sort of like layers of validation that bring rigor to how cryptocurrency works. In fact, what it's trying to do is solve this thing called the double spend problem. And by the way, the paper that was written by Satoshi Nakamoto in 2008, really what it's about, whilst it's about the emergence of digital money, it's really about solving this idea of the double spend problem. Now you can think of it just like this. The same ways you can easily copy a file on your computer multiple times without incurring any cost, if we had digital money without any type of mechanism to provide it with integrity, we would be copying money multiple times and sending it to people. Well, that wouldn't work because you'd have unlimited money and the system wouldn't work. So what we're trying to do is solve this idea that how can you send the same money to multiple people? We want to eliminate that. So when you have a unit of money and you spend it digitally, you no longer can use it again. Okay, and so that's at the core of solving digital money in the 21st century. And the paper does that. It does it with miners. Miners have to do certain activities, and it does it with this notion of consensus. Now you might think Bitcoin is all there is. Well, there happens to be almost 2,000 other cryptocurrencies, and they all do different types of things. The original code base for Bitcoin, which was written in 2009, is open source. So anybody can copy it and create their own crypto if they want. Now, what does all this mean? Let's look at a few examples. And we'll talk about the financial sector. So one of the qualities or challenges, I should say, of the international monetary system is when we want to move money today from one country to another, these are sort of inter-territory transactions. There are lots of overhead. There are things like cost. So if you've ever sent money to somebody in another country, you have to pay a fee, and it might not go fast. Typically, I've sent money to another country and it can take 3 or 4 days. Unless you're willing to pay a big premium, typically in a bank it takes 3 or 4 days to send it somewhere in the world. There's a lot of fraud that happens on the international monetary system too. And overall, it's not terribly efficient. So how might you solve that in a sort of a digital money world? Well, one solution, for example, is called Ripple. And what Ripple does, it enables people to send money almost immediately. So it uses the unique nature of not needing intermediaries, because remember, blockchain fundamentally is decentralized, right? And it doesn't have a central governance. So units of value can be sent from one area to another by mining and by consensus. So Ripple solves the problem of the cost and the time it takes to send money around the world. That's quite disruptive. I mean, it has a lot of value. Ripple is getting very, very popular. Using cryptocurrency has allowed a new form of raising money. In fact, there's this idea of what's called an initial coin offering, which enables organizations to allocate parts of their business to investors through the allocation of cryptocurrency. And this was popular for a while. Right now, it's not so popular. And in fact, it's evolving. But it does hint to us the idea that crypto can enable things that were typically hard, like raising money, because there was only a few ways we could do that, into a much more accessible form of raising money for much more participants. And that's good, ultimately, for the global economy. So again, as a reminder, blockchain is that sort of underlying database and set of technologies that enables these, not only these financial transactions to be done differently, but a whole range of other applications. Another one I want to talk to you about is supply chain. And I want to use the example of diamonds. So when we go to a store and we buy a diamond for a ring or a diamond that's in a ring or earrings, we are looking at a certificate that says that the diamond came from a place that was ethical, and we hope that's the truth. Unfortunately, there's been some bad history in certain places in the world. The revenue from diamonds is used sometimes to fund war and civil unrest, and we want to make sure that the places where we get diamonds from are not used, the funds are not used for those purposes. So we're interested in the supply chain for diamonds. Well, let's think about how we might do that differently using a blockchain database. So blockchain database, first of all, is decentralized, so no one can control it. No single individual or entity can control it. That's good. Number two, it records all transactions because it's immutable. We don't delete anything. And it's secure because it has cryptography to enable authentication of users. So those and others, and we'll discuss these more in the broader course, enable us to track things across the supply chain much better on top of a blockchain database. And so a company called Everledger is doing this with diamonds and having some great results. The same thing can be said for the shipping industry. Because in the shipping industry, when products flow onto a ship and off a ship in different countries. There are sometimes hundreds of transactions that take place that are open to fraud and central management and cost and inefficiencies. If you can do that now on a blockchain database and have everyone participate, the efficiency of the global shipping system can be improved. And there's great work being done by Maersk and with IBM to utilize blockchain in this context with great results. Now, we've been talking about Bitcoin as a type of blockchain database, but there are many, many others. One of the other blockchain systems that is probably the second most popular is a platform called Ethereum. And Ethereum also has a cryptocurrency. The cryptocurrency is called Ether. But what's interesting about Ethereum is it has another blockchain feature that we talk about in great detail in the course, which is called a smart contract. And so what is a smart contract? A smart contract is basically software that runs a traditional contract and executes transactions under certain conditions. So there has to be certain triggers that do things. So if we think about for a moment my example of the shipping industry, there could be multiple people who have to be paid and multiple documents that need to be distributed at certain predictable times. Wouldn't it be better for the software just to trigger that rather than waiting for people and all the inefficiencies and even the reliability of waiting for people to write checks? If a smart contract running on top of an Ethereum blockchain can do that, that adds even more value to blockchain in the supply chain context. So smart contracts are being used for a whole range of interesting applications that we'll explore later. And for example, here on this screen we have examples of what's called an Ethereum catalog, which lists all the different applications that people can use in a variety of contexts. Now, we've been talking about public blockchains. A public blockchain means it's accessible to everybody. So Bitcoin, you can participate in Bitcoin. Any one of us can be part of Bitcoin, but there might be a time when it makes sense for blockchain to be used just in a private context. For example, blockchain within a single enterprise. But we want all the features. We want the distributed nature, we want the security, we want the speed and the efficiency and the lower cost. We want all those things, but we don't want it in a public context. And there are solutions too for that. One of the most popular is a solution called Hyperledger. Hyperledger was built by a consortium of tech companies and other types of companies to address this desire for a private blockchain. There's some very unique qualities to that. There are other platforms, for example, the product called Factum is doing a whole range of new solutions using blockchain technology. And in particular, they have a solution for managing mortgages more efficiently. So where a traditional mortgage transaction may have many forms that require signatures and even some discovery work, and the forms need to move between different stakeholders. This is an ideal platform for blockchain where you want to have high integrity to the movement of these documents and you want to know who owns them, where they're going. And when you identify a document, you want to be totally confident that the person who claims to own a document, or let's say in this case, a piece of property or land at a given time, you want to have total confidence that that's accurate. And Factum is trying to push that innovation into the marketplace. Another area where blockchain is starting to be adopted in a broad way is in government, in local, state, and national governments. There's plenty of uses, and I've just listed a few here. Everything from storing information securely on personnel, recording academic credentials and professional licenses, all sorts of records management, everything from criminal records to birth and death certificates. And another really compelling area of ID management. If we can have really good identity management, we can start to do cool things like vote online, vote on our smartphones. This is a difficult problem to solve, but there's some fascinating and successful experiments in doing voting online using blockchain technology. So this is going to come into focus in the years ahead, because it's something that many of us want. We want to see this. We want to be able to vote, have good ID, and know that our vote is counted and it can't be corrupted. And we see some great experimentation being done in Switzerland in this area, in particular in the city of Zug, or what is now known as Crypto Valley. Dubai in the United Arab Emirates, they have an ambitious plan to run most transactions using blockchain technology as the enabler. They're making some progress, and they'll continue to innovate around this over the years ahead. One of the examples I particularly like is how the World Food Program is using blockchain technology in a pilot program to distribute funds faster, and also that the funds get to the people it needs to go to. Because when you have a charity like the World Food Program that is distributing millions and millions of dollars of money and funds per year for needs, you want to make sure it gets to the right people. And they've been doing some great experimentation with really, really good results. We'll see blockchain as an enabler for the Internet of Things. This is exploding. We're connecting everything. And blockchain may be one of the ways in which we build better security into the IoT infrastructure and allow devices to have the ability to work together without having central authority again, but being able to distribute logic. And we might do that through use of smart contracts that I discussed previously. In fact, there's a whole space of blockchain technology deliberately for IoT, which is called IOTA, which I encourage you to research. And it's specifically for enabling the Internet of Things using blockchain technology. We'll see blockchain used in healthcare, right? And in this example I'm sharing with you is how can we make sure that, first of all, the medicine that we think is being transported, that it's real medicine, it's not fraudulent or fake medicine. And as it goes through the supply chain, if, for example, it needs to be kept at a certain temperature, can we be sure it was at the right temperature through the entire supply chain? This is hard to do. I mean, we do it today, but it's hard to do, and it's got all sorts of weaknesses. Put this on the blockchain and we can start to solve some of these important human challenges that we've had. So where are we with blockchain? Where are we today as we come to the end of the second decade of the 21st century? We've come a long way. Well, blockchain is only 10 years old, so we've come a long way in 10 years. And the best stuff is yet to come. It's moving from being a novelty into a mainstream technology, being adopted almost in every industry, in every economy in the world. It's got great uses and varied uses in many, many contexts. But we're still at the start. I like to think of blockchain being where the internet was just at the arrival of Amazon.com. So there are some really exciting things ahead. I'm very positive about this technology. There are risks and there are some unknowns, but it seems to be headed in the right direction. And to learn about it now and to begin to think about it in the context of your life, your organization, your business, that's a very good thing to do. That's competitive advantage and has tremendous value to be learning about the role of blockchain today. Thank you so much for watching, and I look forward to seeing you in the course.
Oh, thank you very much, Jonathan. It has been a pleasure sharing your knowledge about blockchain. Y a todos los demás, nos vemos en el curso de Blockchain UC Berkeley con Jonathan.